This is the second part of trig identities. We've got two so far, and we're going to look at how we're going to use them to simplify our calculations with trig values. So just as a recap, we've got tan theta is the same as sine theta over cos theta, and then we've got this new Pythagoras looking identity that says sine squared theta plus cos squared theta equals 1. Okay, one note I want to say about this second identity is that, well, both of them in fact, is if you change the argument, as in if you change what theta is in your expression, then the argument still holds as long as it's put everywhere. So as an example, if I were to write sine squared of 4x, and then I add cos squared of 4x, as long as my argument is the same throughout my identity, it's still going to remain true. So sine squared of 4x plus cos squared of 4x, according to the identity we've got over here, that's 1. Similarly, I can do things like this. I can do tan of theta plus 10 degrees. That's going to be the same as sine, and then I've got to keep my argument the same, so it's sine of theta plus 10. And then I'm running out of space, but I'm going to divide by cos of theta plus 10. Okay, there you go. So that identity is true as well. Right, so how do we use these then? So, well, suppose you've got an expression with lots of different trig values in it, like this over here. Well, we can use the identities that we've got to make it simpler, to reduce it down to something that's a lot simpler like this. So if I'm going to show this identity is true, I'm going to take the complicated looking side, which is obviously the left, and then where I can, I'm going to apply my two identities, and it will hopefully simplify to what's on the right hand side. So the left side, it's 1 minus, okay, I've got a tan theta. Tan theta I can write as sine theta over cos theta, and that looks like it's going to go well with the sines and coses over here. So I'm going to write sine theta over cos theta. I'm going to leave the sine and the cos because of what's going to happen next. And as you may have spotted, so now we've got sines and coses together. There's a cos here that cancels with this cos here on the bottom. And then over here, I've got a sine theta times another sine theta. And with our new notation, I can write that as sine squared of theta. So the next line is to say 1 minus sine squared theta. Then, according to our second identity, with a bit of rearranging, if you have 1 minus either of these squared values, you're going to get the one that's remaining. So 1 minus sine squared, well, that's just the same as cos squared. And then your identity is done because you've proved it's equal to the right-hand side.